Hello, bonjour. Welcome to a partnered webinar presented to you by Emyode and Microsoft. My name is Jean-Paul Izot, and I'm the Chief DevOps Practitioner at Emyode. As a little background there, Emyode is a mid-sized company that specializes in modernizing and managing Azure-based cloud applications. We also have several products to help the aviation industry in their ground handling management. Notably, we have Ground Handling Manager, De-icing Manager, and Training Manager. So today's topic is continuous delivery and continuous integration using Azure Devops as your automation platform. In just a moment, we will present today's program, so let's get to it. So for today's topic, continuous delivery in Azure DevOps, we've already gone through the introduction of the host, that would be me, and then we're going to go through Azure DevOps, an introduction of the product itself. It has many features. And then we're going to talk agnostically about what continuous delivery is and how it contrasts to continuous integration. It should take about 10 minutes. And then we'll deep dive into the meat of what is continuous delivery and how it's done in Azure DevOps. So we'll be looking at builds, triggers, and later on we'll be looking at release management. And following that, the Q&A that should last 2 minutes to 15, up to you guys. To address these, notably, we have Azure boards, Azure pipelines, Azure repos, Azure test plans, artifacts, and the extension marketplace. So here we are in our dashboard for our Azure DevOps project. So I've already started a project. It's already defined in Azure DevOps, since we are not going to get into that today. But just as an overview, we have here our summary overview right here. So as you can see, there's a description, the name of the project, what it's about. If you had a markdown file with your README, this is where you would find it. On the right, you have project statistics, builds and deployments, and how that's been going. Boards with work. The repos is where we store our code. And here we have our pipelines. And this is where we're going to be spending most of our time today. So pipelines are defined in several stages. Pipelines themselves, which have been in the past called builds. We have environments, and those are set to create or conceptualize different Docker container clusters or environments. Releases, which are the actual release mechanisms or the delivery mechanisms of the software. We'll get into that in a minute. Library is a place where you can store things that need to be shared between pipelines. So let's say you have a series of global variables that are used in all kinds of different pipelines. Well, this is where you would generalize them. Task groups are an interesting concept for maintenance. So in a little while, you'll see that when we're preparing a pipeline, we're going to be defining tasks, and those tasks, if they are going to be reused in the pipeline for every stage, for example, in integration, in QA, in UAT, and we keep reusing these concepts and these tasks, well, if we had, a group of them that were set together, then when we want to maintain them, it would make it a lot easier. So that's what task groups are about. We'll have a look at those later. And deployment groups, same concept, but for when you do deployments, perhaps you will be using regions to define different parts of the world where your application exists. Well, you would define an application having a group in Asia, a group in Canada. Well, that's what they would be used for. So I really wanted to take a minute to talk to you about the horizontal integration that there exists in this platform before we deep dive into the pipeline. Because as you will see when we're going to make code changes, it's going to set off a whole trigger of functions that will at the same time describe why this is being done as a report to the planning, the work, the boards, and the repos. And also further down the line, when we're going to look at what has been deployed, we'll be able to track from that point on all the way up to, well, exactly what was the ask, what were the tests, and all of those suites. So I mean, there are other products in the industry that do some of these things, and even some of these things together, but having this all integrated from the moment the work is planned, delivered, how it relates to the code, how the code was reviewed and tested, how the code reviewed and tested ended up in which packaging, and how that was eventually deployed and where did it get deployed to. There's nothing I found right now that can do all of that in one single suite except for Azure DevOps. So later on in the Q&A, if you guys have found something really interesting and you want to talk about it, I'd be glad to hear about it. But as it is right now, this is the state of the art as far as horizontal integration is in a DevOps cycle. So Azure DevOps, as a name for a platform, is very, very adequate. So now let's start having a look at how a pipeline is defined and how it's operated in Azure DevOps. The first thing you need to know is that there's two types of pipelines that are possible in Azure DevOps. And the first one that I'm going to introduce is the one that I'm actually using. And it's called a YAML file. And basically it's a text file in which we have defined the steps and the parameters of what we want to have done. But there's another way that if you are fairly new to creating deployments and build pipelines that you might find useful. And in this particular case, it's using a tool that they used to call VNext steps. And it's a more graphical approach to creating a build. So we're going to have an option at the bottom that says, and use the classic editor. So what is the classic editor? Well, the classic editor, it's kind of a wizard, so I'm going to indicate that we're going to do the Git repository again. And yes, this is a test project. Team, yes, which branch? So far so good. This is the source where I have all my code. Now, how do we want to do this? Configuration is code. We don't do a YAML. So let me start with an empty job and see what that looks like. Right now, the only thing I have defined is where my sources are. So this is my pipeline, where my sources are, and an agent job. So an agent is basically a workspace with a service that executes commands. So back in the day, we'd have these installed on a particular server called the build server. But now in Azure DevOps is something that's hosted in the cloud, so you don't have to maintain this infrastructure anymore. But you still have agents, and the same concepts that at the time were useful to know, like the platform that's going to be used to be doing the build, remains pertinent in this case. So if I look at my agent that I can select, I have a couple of options. And if I go into Azure Pipelines, which means the hosted version of these agents, I have several types and versions of operating systems on which I can perform these builds and deployments. And what you have to remember here is that this is completely agnostic to the type of code you do. So you would assume, or you may assume, that because this is a Microsoft platform, it's made for building, .NET or C# applications or Windows Unified Platform applications. But no, really, you could be building any kind of application, whether it's Java, PHP, or any of those other languages. So sometimes you need to leverage a different operating system to do that. You have the options here. But for example, today we are deploying a .NET application, so I'm going to go ahead and select a Windows box. And well, I've defined my agent right now. There's several options for building, including parallelism, sorry, that's a difficult word to say, multiple configurations, because you could say that you want to deploy at the same time your debug stack and your production stack. So just be careful about these options here that you might want to look into. But in order to get straight to the job and to demonstrate what I wanted to demonstrate, I'm going to go ahead and save this. So I'm just going to save it. I'm not going to queue it. No comments or anything like that. But notice on the agent now, there's a little plus sign, and this plus sign allows me to put in different tasks. So if you recollect before when I was talking about task groups, so if I want to deploy, build an application, the different steps, there's some that are configured for you that are very graphically user interface friendly. There we go. And CMake, Docker, Go Code, Gradle, Grunt, Gulp. I mean, they're alphabetical, obviously. But let's say that we're going to do a Visual Studio build, and then all you got to do is fill in the parameters here where your actual solution that you want to build is, and then you're done. So for somebody who is starting out trying to create a build pipeline, this could be a good way to go to quickly learn how to do it. But for the remainder of our webinar today, we're going to be using the YAML file, but just understand that there's this other option that you can use to make this a little bit simpler if you're beginning. So let me get back to the pipelines, and we'll get rid of this guy. And we will pursue using our YAML pipeline. So I have two of them here. One of the concepts that I would like you to understand today is that since we are going to be deploying an application that is hosted in the Azure cloud, my infrastructure is actually code. So hypothetically, this code exists independently of the actual application itself. It could be integrated, it could be a step where you instantiate your infrastructure just before you set out to deploy your application. But in this particular case, I wanted to show you how we did things and where we've given some autonomy to the infrastructure teams, or what we would traditionally call the op teams, so that they can better integrate and get things done quicker and deliver quicker to the dev teams when they want to get set up. Let's go ahead and dive into this guy here. Oh, and by the way, I should show you this right away. I have created a repo that is restricted and used by infra, and it's right here. And within this, I have a YAML file. So this YAML file has the build definition tied into it. So let's have a look at it. Basically, since we're doing infrastructure as code, there's actually nothing to really build. There's no compilation, let me put it to you that way. However, there are artifacts, there are things that we want to have packaged and bring up to the cloud, and these are called ARM templates. So the short ARM acronym stands for Azure Resource Management. So basically it's a JSON file that defines what your infrastructure is going to look like. We're going to have a look at that in just a minute. So if you notice here, the very simple thing is that, well, I'm going to grab the files that are in scripts and in templates, and that we're going to put this in our drop container, and that's going to be consumed by our deployment pipeline. Let's have a quick look at these infamous ARM templates. I have several here, but the one that I'm going to be using to deploy today is called the Azure Deploy 2 JSON file, and as it is, it's kind of difficult to read. It's a JSON file. I mean, some people are hardcore, they can read this easily. I'm one of the people that's going to use the tools to make it as easy as possible. So I would recommend you use Visual Studio Code. And there's an extension that allows you to look at your ARM template as a tree of objects. The tree of objects itself is the schema, the content version. If there are any parameters, we'll explain the parameters in just a little bit. And variables, explain that also in a little bit. But I wanted to look at the resources and show that I've defined in it a SQL server, and when I click on it, boom, it brings me to the context. Same thing for the hosting plan. So all of the web applications are hosted under a plan which gives them the computing power. The website itself is the web app. As the analogy for people who use IIS is that, well, you have a single instance of IIS on a computer, and that's the app hosting plan, but a different website's hosted within that IIS. That would be the different web apps, or this website right here. And we have some app site components. Now, the app site components I find is not very optional, and I'll explain to you why. If you want to understand exactly how your application is doing once that it's put out there, having something that monitors them in real time in order to alert you to any problems that may arise is not really an option these days. And for the little effort it takes to have these integrated in your web apps, I'd really recommend you to consider it before you go ahead and deploy a web app without it. So this ARM template is generic. It defines my SQL server, the database within. If I open this here, there is within a resource, and you see there's a database that's inside the SQL server, and there's also some firewall rules to allow me to traverse between my Azure infrastructure so that my website and my SQL server can talk to each other. essentially, I didn't want to give you a classical course on ARM templates, but understand that this here defines the infrastructure I'm going to have. So this is an example of infrastructure as code. You could also do this in Azure CLI, which is basically a command line, and you could script it, and you can also do this in PowerShell. So there's several ways you can do infrastructure as code. But in this particular instance, the interesting thing is that you have a view on how it's going to be deployed and look like hierarchically in its target. So just a very quick look at the parameters. So I've defined here allowed values for the size of my website SKU, so basically my stocking keeping unit number or name for my website, and this is going to define the kind of power I'm deploying. So I can define these here with default values, and I also can have a parameters file that is going to be consumed later on, in which I can have several files defining several environments. So even if I'm deploying the same ARM template in dev, in UAT, and in production, we will have a file like this that defines, well, how it should be configured when it's in dev versus UAT versus production. So that's one of the ways of doing it that is very easy to follow up, just like you follow up on code. What are the different states of infrastructure? So for anybody who is trying to maintain, and if you understand with the concept of a CMDB, as a content management database, it's very easy to look at these JSON files and understand, like, well, if it's in dev, this is the configuration it has, right? So I find this very useful. Getting back to our pipelines, let's go into the pipeline that is associated with our infra repo that we were looking at just a moment ago. And when the interface opens, you'll see the state of the different builds and deployments that were done in the past. So if we edit it, interestingly, it's just going to point to that YAML file we had in the Git repo a moment ago. So here we are again. We have our Git repo file that has our different steps and a definition of where it's going to be hosted and how it's going to be built, which is essentially just copying and packaging the files. But what I would like you to notice is that if I wanted to insert another step in here, it will write part of the code for me. So if I just, type something here and I say add, it does do part of the code for me here and insert it where I want it to. For people who want to initiate themselves to YAML, this is a good way to have an intermediary way to get to build your pipelines. So now I've navigated back to the repos, and I have selected my test project in which I have my web application. So just like I had a pipeline that defined how infrastructure is going to go, I have a pipeline that's going to define also how my application is going to go. Now, one of the interesting features of Azure pipelines, Azure Devops pipelines, is if you have a YAML file that is conformly named based on the Azure-pipeline something.yml, if you save that in your repo and you come back here, you're going to instantly have a predefined pipeline. Since all the steps are there and all the definition of the pipeline is there, Azure DevOps will interpret that and it will set up a pipeline for you. So you'll have a way for you to edit it and execute it and follow up on it, but the actual definition itself is going to magically appear in the pipeline simply because its name is defined on that standard YAML file. But if you didn't like the name as it is and you wanted to choose another one, when you're doing the editing in the settings, you can change the name. So as you saw before, the one that I had for infrastructure, it wasn't called that standard name, and I defined it myself. So you can do that easily if you want, when you create your pipeline, and just use a different file. But I find this interesting because if you are doing something that is reusable, and people who do code like to do things reusable, and one of the objects of our webinar today is to do things that are reusable, having this hosted and having this pipeline being able to be reused means that if you grab this code here, and this is a very basic website with a hello world that is a good starter for a project. If I upload this to a different repo in Azure DevOps, well, my developers, as soon as they get in, they already have a pipeline built for them that can build the solution that that has been set up for them. So it can really accelerate the way you do your work if you use it this way. I just wanted to go over the steps quickly with you guys in order to see what we have here. So again, I've hosted this on a 2017 Windows machine. These are these are the tools that I've required to have for my product to build. So there's MS Build, there's Visual Studio, and Visual Studio Tests. I'm not using Visual Studio Tests in this webinar because it is a webinar in itself. But just know that I could have defined here some tests because I have in my demand set, I need to have this deployed on the build server. So the different steps, NuGet tool installer. NuGet tool installer is going to make sure that my NuGet tool is going to be up to date, or at least at the version that is expected to make my application work. So in this particular case, we're using NuGet 4.4.1. So that makes sure that that's installed and it's updated. The second step would be obviously doing the NuGet restore. So I have defined here the solution or the project. In the case of a .NET project, it can be a CSproj file or SLN file. But basically, you can have your project defined here, and your NuGet restore is going to base its restore on that project. And then I have my build task, which grabs the solution and builds it for me. And since I have defined in my Microsoft build arguments where to package everything, so here's the output path, I can later on use this environment variable. So environment variables are a handy way of either storing temporarily or having the application store for you things that are going to be reused later. When we get into the pipeline deployments, we're going to get into environment variables a little bit more, but just know that you have placeholders like this that is defined with $ and some words within. Some of them are reserved, like this one, which allow you to carry over some of the information you had in previous steps. So just keep that in mind for later. This is our pipeline. I guess we could test building it in just a moment. Let's go back to the definitions. And look how things have been. So 4 hours ago, a little bit before I did the webinar with you guys, I've fired up these deployments, so they're already done. There's not a great interest in looking at them deploy, but for the reasons of at least being transparent, I just want to show you what it does look like when it runs. And here I get to define which code I could pull from a different branch if I really insisted to have a earlier featured branch being built for a potential deployment. But let's just run the master one. And that gets fired up. So it gets queued up. And then Azure Devops Go looks on the cloud to see which agent is available to do the compilation of your code or the packaging of your code. Once it finds it, it fires it up. You can click on it and go have a look at the state if you would like. So it's a very short thing. It just pulls from the repo the files, as you can see. And you can see they have an audit here of which exact files it was pulled. Publish artifact, they grabbed all the files and they put it in the drop folder. So this is a very short and quick example of what a pipeline looks like. And in the case of web deploy, we'll look at a historical one. So same thing, each of the steps is defined here, and if there was any problem, there would be a little red X here instead of a green check mark. But you can audit the different steps, checking out the code and grabbing it, getting the NuGet, doing the restore, building the solution, all the steps. The output is in the log file here. And this is basically what creates your package. So in trying to understand what is continuous delivery, it's really important to understand that there's a distinction between continuous delivery and continuous integration. So the continuous bit is obviously common, but integration versus deployment is a little different. So put very simply, continuous integration, when we're talking about integration, we're talking about packaging, assembling the part as a whole. There's usually what we call a build or a compilation. So the code usually does not exist as it was when it was source code. It's assembled, it's compiled, unit tests will be done there. Everything that needs to do to make sure that everything is integrated, that it is correctly put together, which is, I guess, the standard definition of integration. So continuous integration is making sure that every time you submit something that is part of this integration package, it is done as a step. So in the example of our continuous integration package that we have in Azure DevOps and our pipelines, I've defined a trigger in the case of both the Git infra pipeline and the web deploy, that every single time you commit some code to the repo, so if I made a change, let's say, to my YAML file, I'm just going to add a space here and commit it. When that gets done, what happens here is that it notices that there was a change, and then therefore it acts upon that change. So acting upon that change is making sure that if I submitted something that would be problematic in the integration of everything being put together, I would find out immediately. So this is the value of doing something continuously. Now, obviously, having something that is potentially defective ending up deployed somewhere doesn't have intrinsic value. I mean, you don't want to deploy anything that is not working or is broken. So I guess that would be the very best way to distinguish what continuous integration and continuous deployment is that, well, continuous integration is making sure every time you submit something to be part of the packaging, it is attempted to be packaged. And continuous deployment would say, like, well, when you do finally get a valid package, let's make sure we've put it somewhere that it's actually testable or operationalizable so that you can actually use it as an application to find out if that integration went well. So I just wanted to take a minute to make the distinction between continuous integration and continuous deployment, because it's kind of difficult to explain it to the business stakeholders, but the value really is making sure to find out as quickly as possible if we're going to have any issues where they are, not wait until something is deployed in production and finding out, well, I have a problem now. It didn't integrate well. So understanding the value of continuous integration and how it's easily set up in Azure DevOps is part of what we're doing a webinar here today for you to understand and see it for yourself, that a simple code submission will fire up a pipeline, and this pipeline will try to integrate the changes, and if the changes do make sense, well, then it will be a product that is susceptible to be deployed on the cloud. So as you can see from our little green check mark here, our build has, our packaging or our pipeline has run successfully. It took about 1 minute and 7 seconds. It's a very small project. It's not a big surprise. So that would mean conceptually, as far as deployments go in just a minute, is that we have now a candidate that can be sent forth in our ecosystem of different environments to be consumed. Now, we're going to be looking at releases in just a moment, and in those releases, you will see that there is a chain of events, and following these chain of events, we're going to progress between early testing phases and deployments into production. And it's very easy to do in Azure DevOps. It's ridiculously easy to do. Just keep in mind that we're always basing ourselves on a single package, and this candidate is either going to be promoted from environment to environment as we find out it is what we were expecting, and if not, it is going to be rejected as soon as possible so that we can go ahead and make code changes again and make those code changes appear in another candidate for deployment, and that this candidate again is going to go through the cycle of being promoted from early testing phases to eventual production phases. Just before we move into our releases, I wanted to highlight the last changes that I had to my infrastructure repo or my ARM templates. The last changes were defined as version 1.0.1.4.1. So I just want you to keep that in mind, because when we're going to be moving forward into the releases, it's going to be defining in order to follow up exactly which version of my packaging is going to be deployed. So let's go ahead and go into the releases right now. And as a feature of this webinar, I wanted to demonstrate just how easily it is to define the pipeline. So we're going to take 2 seconds and define a pipeline based on the packaging that we have for our infra. So let's go ahead and create a new one. So there's a wizard that's going to tell me, you know, exactly what you want to do, and I could choose my steps before, as I did before, saying like, oh, this is what I want to do, and these are the steps I want to do. But just for the sake of this exercise, we're going to try to do this manually, so you understand the general concepts. And it's immediately going to ask me, well, what are you going to call this deployment? So what is this stage called? So since we were talking about promoting your product from testing phases to production phases, each of these phases, or stages as they're called in this case, are going to have names that are going to be associated with them, so that you know where your code is deployed. So for the sake of this exercise, let's call it integration tests, or just int for short. I don't like to have long names for nothing. That's done. Save. And one of the things that this is going to require is a series of artifacts. So the series of artifacts are usually associated with a build, but you could have them stored as is in a repo, because it could be something that a different company builds for you and sends forth and just checks into your repo. But in our case, we actually have a build, and in test project for our infra, that build is called get infra repo. And there's a couple of questions here like, well, which version do you want to use? Do you want to keep using the last one at the time of the last release creation? The latest from the build pipeline, default branch with tags. So you could tag a branch and say like, well, you always use the one that has this tag, so you could have a moving tag, and then the build and deployment would know which branch to follow it on. There's a couple of rules here that you could, but I mean, for most cases you want to have the last version of the code. So let's add that. So now we have from whence the packaging is going to come from. We have this little lightning here that is going to define if we want to have a continuous deployment. So do we want, after each time we have a successful integration, a deployment in this environment? We absolutely do. So this is all of the value of having a continuous integration, is to have this continuous deployment trigger. So every time your build succeeds and it manages to package something, it's going to end up somewhere. It's going to be deployed somewhere. You can do something with it. You don't have to wait. So all the interest of having a continuous deployment is by checking this little thing here and saving it. Now, we've told them, yes, it's very nice, I would like to have a continuous deployment, but we didn't tell them what to do exactly. So in the interest of actually doing the deployment, we have to decide which kind of step we have to add next. Now, in this particular case, if you remember, we were trying to deploy some infrastructure as code. So let's look at the steps that we have that allows you to do such a thing. So it's a deployment. So let's look at the deployment tools. App Center Distribute, no, we're not doing mobile apps. We're not deploying a web app. We're trying to do infrastructure, app service settings, CLI. Oh, there's a command line. No, that's not what it is. Cloud service deployment, that sounds kind of right, but I don't think it is. Functions, Key Vault, PowerShell, resource group, ARM templates. So this must be the right one. Let's go ahead and add it. So immediately it tells us that, well, it has some information missing to be able to proceed. So you couldn't even save it as it is right now. One of the information that it needs to know is, well, if you're deploying infrastructure in Azure, well, in which subscription are we deploying this? So each of the stages can have a separate one. So in this particular case, I'm going to use my development one. And it's going to ask me, do I want to create or update a resource group? So I have different type of deployments. It could be I want to create, configure, start virtual machines, stop and deallocate virtual machines, delete a resource group for some reason. But we want to either create and update a resource group right now because we want to deploy an infrastructure that we didn't have just before. So the name of the resource group, we'll call it RG for short, resource group, and test webinar. Now, the location of the resource group is going to make all the underlying infrastructure dependent on the location of that resource group. So, in this case, if I'm deploying, let's say in central US, all of the underlying infrastructure of that resource group that I am deploying is also going to be in central US. And in the case of MSDN subscriptions, central US is a good choice because it allows me to apply all of my stuff in one single place without any issues. So let me put that there. Template location. So where is it going to get the ARM templates that it wants to deploy? Well, it could be on the web somewhere, but it could be linked to as an artifact. So think of it, two different mechanisms that you publish on the web somewhere, the ultimate version for your ARM templates, but that would require security to make sure that not everybody else can download it. It could be complicated. But there's a simple way, is like we did before. We just grabbed it from our repo, we packaged it, and we sent it along. Since we have it in our packaging here, so we can browse and navigate and go find it in our drop location. And remember Azure Deploy to? There it is. So sorry about the color scheme. There seems to be a little bit of something funky going on when you use the dark scheme, but you can see here on the bottom it did select the right file. All right, so I got the template. So what are the parameters? So here I can define a file that is going to tell me exactly what the parameters are. So they can be stored in a file. So they can make your life very easy. You can have several files and one for each stack. You can use environment variables to define the name of the file. But in our particular case, I would like to be able to set them manually. So in order to set them manually, but at the same time make it maintainable and easy to maintain, we're going to be using environment variables, or just variables for the remainder of this webinar, in which we have already determined what are the different names, convention sizes and whatnot that we need for our deployment. So let's go into the little variable tab here for a second. And I really want to emphasize the use of this link here, which just says predefined variables. So the predefined variables, there's a website that's going to pop open here. So these predefined variables are all the variables that are about how your pipeline is already set up. I recommend you read this documentation attentively, because if you wanted to know, for instance, which of the stages that you're deploying in right now, which is going to be useful for us in just a minute, there is a variable that's predefined that tells you that. So variables are a very powerful way to pass arguments or pass information along as far as the deployment is going to be going. So without any further ado, let me go back to our release pipeline. Understand that you have also variable groups that you can use. Having variable groups allow you to share variables in between projects. In this case, it could be pertinent. I have some defined global variables, and in these global variables, you would see that I have an ID for my client that is defined, an ID for my product that is defined, and that is going to be helpful in determining exactly how my application is going to be deployed. I'll show you that in just a second. So I've moved on now to my real quote-unquote production type of deployment definition, or my release definition. And we're back at the box here where I have my override the template parameters. So as you can see, the ones I had in my variable groups are now being consumed but I also am consuming one. When you see a variable that is separated with a dot something, is usually a predefined one. So I'm also consuming something that the system is giving me in order to determine what my application looks like. So it looks a little daunting this way, but once you have the parameters defined in your ARM template, you get this little GUI that you can use to come and put in the different values, and it will construct these this argument chain for you. So in this particular case, I have the administrator login. I have the login password, which is hidden inside a variable, the name of the product, the claim, and the environment. And I'm going to show in just a minute how that is pertinent to what my application is going to look like. So I just wanted to review quickly with you the rest of the parameters here that are set up. So what is the deployment mode? If it's incremental, it's complete, or it's validation only. Validation only is if you wanted to do a test and make sure that it's going to function and not go through the entire cycle of deploying in and of itself. Incremental is, well, if there is nothing there, build it, but if there is something that comes along, make only the necessary changes in order to have it conform to your new version. Let's say you're updating your infrastructure and your database is going to remain the same, your web app is going to remain the same, but your application insights is going to have a new alert defined in it. Well, that's the only thing that's going to get changed. So that's the concept of incremental. So complete, it would be every time you deploy everything, because we trust no one. I can't give you a very good use case right now why that would be useful. To enable prerequisites, usually when you're doing this kind of deployment, it's not necessary, but you may want to configure with Windows Release Management Agent or a deployment group agent. So remember we were talking about deployment groups before. So if you have many agents coordinating the deployment of, let's say again, regional deployments, so you may want to require to make sure that this deployment happens on those agents for it to be deployed across the world instead of in one single area. Deployment name, well, for people who are familiar with the Azure portal, every time something is deployed, there is in Azure itself a deployment, a definition of something that has been done, tracking of it, and you can give it a specific name for you to follow up on it if you would like. And deployment outputs is, well, if you had steps that further down are going to consume this deployment or something that came out of this deployment, you could define it here so that it can be reused later. I don't use that a lot, to tell you the truth. So I wanted to get back for a second about this horizontal integration thing and how obsessed I am with it. So we're looking here at releases that have already had passed and functioned perfectly and everything was fine. But I wanted to demonstrate how easy it is to trace back the changes that initiated this change. In case the application did not respond as we were expecting, somebody managed to crash the application by doing something that they've always done, and we want to find out exactly how and what the changes were in the code. So the first thing you do is you click on the released version, and so you could have tried to release the same version 2 or 3 times, and because you're having infrastructure issues, you'd have the same build number that's represented more than once. So you would have 10.0.1.41.1, 10.0.1.41.2. So every attempt at deploying has a different revision number as the deployment itself, but the version from which it comes from could have not changed. So maybe you've tried 3 times to deploy and have had no success because your infrastructure isn't responding properly, but your package is fine. Or you could go into your package. In that package, when we see the job that created it, how it was created. So it was manually run by yours truly, and it was following a code change that has this serial number right here. So this looks like it's clickable. Let's click on that. And lo and behold, it brings me to the file that changed. So it looks like, from what I can tell here, all of these little minuses mean that this has been subtracted from the code, and the little plus here says that this has been added. So it looks like somebody took part of the ARM template, subtracted what was hard-coded, and put something that was parameter-based. Well, that's interesting. So we'll have a look at that in just a second. We have a situation here is that somebody changed something about the deployment itself in the infrastructure as code, and the deployment was meant to consume it, and it looks like it consumed it just fine. So let's go have a look at our definition and see exactly how that change has taken place. So it was talking about an SKU, right? So that is true. There is a parameter here that's called SKU name. So I guess I can dynamically define here by changing this value what type of infrastructure is going to be deployed. I'm glad that worked. So before we go any further in how this is all going to be automated in just a second, I wanted to take a moment to show you guys how this thing as a release is defined in a real world scenario. So we have from the repo right here a definition that says, well, every time that a build is pushed, that we have an integration that happens, but we also have, based on this, another part of the release which is disconnected, or manual if you would like. So this part on the top here is part of what we would call the CI/CD pipeline, but the one on the bottom here is not. It's actually a real release scenario. But it would follow logically that after we have a successful integration, then we can start to do additional work in this pipeline, including doing some Q&A and possibly sending it over for approval, and then possibly putting it in production later on. So I just wanted to define and have you visually see how the continuous deployment and the continuous integration are tied in, but how they are disconnected from a real, I'm going to put this in production scenario. They are all defined in this tool easily to be able to do one or the other with automation and ease, but they are also separate in principle, that a continuous deployment is not necessarily going to end up further down the chain, and as a matter of fact, we kind of have planned for it to fail. Now, this is one of the concepts in DevOps that seems a little at odds with everything we've ever done in the past, but failure is part of the process. You know it's going to happen, so you plan for it, so you make sure that whatever you're going to do in the environment where it's supposed to fail is not going to affect the parts that are not supposed to fail. So if you have additional work, if you're counting on an environment to be usable for whatever reason, whether it be testing, approving, or actually end user using, you're not going to be trying to do any failing there. So you stop your continuous integration and your continuous deployment there in that environment so that you don't carry these risks over. So risk management is a big part of being a good DevOps practitioner, and this tool here makes it so easy. So I now wanted to tie this all in together for you guys. I want you guys to see how this is all dynamically integrated and how it all happens effortlessly once you're using it properly. So I'm going to go into my repo, and I'm going to make a change to some of the code, actually, one of the ARM templates. If you remember, we had a default value that it was defined here. I'm just going to change the default value from one value to the next, just so that there's a change to the file and that the system notices that, well, somebody, oh, pardon me, that's the wrong button. Somebody made a change to some code, and what happens next. So I'm going to put S1 here. I'm going to commit this change, and commit, and it's saved. Now let me go check my pipelines here. So my pipeline says, oh, well, look at this, there's something that happened, so I'm triggering a change. The change has now triggered the location of an agent and has been put into queue to build. And if we go in it, we're going to see our steps. That's a very quick job. It took only a couple seconds, so we didn't even have time to get into it, and it was already complete. But what we need to do, we need to understand is that it took this new ARM template that we have, and it copied it over as a new candidate for a release. But shouldn't it have triggered a release automatically? Let's go see our releases. So look at that. There's a release that's been defined, and it looks like it's being triggered as we speak. So just for the fun of it, let's go check our Azure environments and our resource group here where it's supposed to be deployed. So there's nothing here. The list is completely empty of infrastructure right there. There's nothing in there. Let's go back to our release, see what's going on in there. So we're waiting for an agent to be ready to do the deployment, so it can take a couple seconds. So I'm running this on a free developer's MSDN license. Basically, it doesn't cost me anything to do these deployments, but the drawback is that I don't get priority over people who are actually doing paying deployments. So the long and the short of it is that sometimes I have to wait a couple of minutes for my deployment to go over. But what I wanted to take this time to show you guys is if I click on the integration deployment definition, I have here a status of where things are going or coming from. What are the associated commits? I have also here associated work items. So if when I did my commit, I associated a number of a work item, I would see here and have the tracking of these work items. So you can also see it here, but I didn't do any, so you don't see it. The commits here, so I could go directly to the change of the JSON file in the source code. It's another very quick way of finding out exactly what happened with this deployment, but as it's being deployed. I find this very handy. So it looks like our deployment has started, and it's on the third tasks of 3, which should finish very soon. But let's take a second and go see if our infrastructure, some of it has been spawned. So let me refresh this here. Well, look at that. I have some infrastructure. I have a web app. I have an SQL server. I have a hosting plan for my web app. I have a database that's appeared, and I have some application insights that have been deployed. So that was pretty easy, and all I did was change some code. So after a couple of seconds, I have now a release that has succeeded in integration, and as we have looked into our infrastructure, everything seems to be deployed adequately and ready to host an application. So I guess our next step would be, let's have an application being hosted on it, and let's make that application spawn on that infrastructure based on a code change. So here we are again, and I've just put on my developer's hat, and well, somebody said that the website, the emphasis on the hello world wasn't big enough, so I'm just simply going to add another exclamation point to the ASPX file. Let me edit the HTML part of that ASPX, add the second exclamation point, commit, and there should be no surprise for you guys. This is going to immediately fire off a pipeline. But this pipeline now is the application side of that infrastructure that I sent on. Essentially, I've made both teams work together better because they're both autonomous. One of them can increase and change infrastructure independently of how the application has progressed. And the applications team can deploy newer application because the infrastructure is always going to be there ready and up to date. So here we are. No big surprise. Our build passed. Compilation of HTML code is usually quite easy to handle. So let's go see our releases and what happened there. Oh no, there was no web app release. What could have possibly happened? Well, let's investigate. So let me see the release definition. I was like, looks somebody forgot to configure something. So yeah, the automatic continuous integration was not defined, so it didn't get done. So let's define that now and save it. But we can simulate a continuous deployment because the integration already happened. We'll just create a release and launch it. So based on the source code that we had, the version was 16. Let's create a release and see what happens. So the release has been created. Let's go have a look, see how it's going. And it is queued. Again, my free subscription is going to slow things down a tad. Oh, what is this? Our deployment failed. And why could it have possibly failed? So let's look at what happens when the deployment fails. You have a log here that tells you exactly what happened. So it says, error, no package found with specified pattern, blah, 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 hello world. Maybe I should have a look at this release definition again. We're going to, we're not going to edit the release. We're going to edit the tasks. And we're going to have a look here at what we were trying to deploy. So we're trying to deploy a package. This is our folder from which we're deploying. Let's go have a look-see here. Drop, hello world, bin. Here it is. So yes, it wasn't hello world.zip, it was webapp.zip that we're trying to deploy. So the correction has been done. Let's try deploying it again. As you can see, what's currently deployed is that, and since it's exactly the same package, it's going to be the same version again. So we press deploy. We go check our releases. We have one that's running right now. And in this release, which is in progress, we have another failure. What could have happened this time? So here goes our second release of that version after the little hiccup that we had. Let's see how this is going. So far so good. And we can follow the steps and the logs. So remember when I said to plan for failure, and this was a good place to plan for failure? So not that I would like to waste your time with it, but I could have spent the entire afternoon debugging this without impacting any other application on any other stack. So the application has actually completed its deployment, and it succeeded. And the ultimate test is to go in our resources, go to our web app, go to the URL, and see we have our hello world with the 2 exclamation points. Well, ladies and gentlemen, this concludes our webinar. We should have demonstrated how simple, easy, and maybe fun it is to create a continuous integration pipeline and implement it in a continuous delivery scenario using Azure DevOps by Microsoft. If you would like to try these exercises for yourself, the code used in this demo is generic and available on GitHub. Please contact me at the address below. And remember that everybody that wants can get a $200 credit for free Azure Cloud hosting to experiment. And I would like to thank you for joining me in the name of myself, Emyode, and Microsoft. Please come and watch us again for our next webinar. Thank you. Bye-bye.